Good day. Let's now turn our attention to conditional probability. So for any two given events, A and B, the conditional probability that A occurs given that B has already taken place is equal to the probability of the intersection over the probability of B, the latter event. Right? That is key. So let's check this out with the aid of an example. We have two events, C and D, such that probability of C occurring is 4/7. The probability of C occurring and D not occurring is a third. And then the probability of the conditional probability of C occurring given that D has already taken place is 5/14. So 1, find the probability of C and D. Now, the way we can solve this is we need to remember that for C to occur, or the proportion of the elements that will go in set C, if you think of it in terms of the Venn diagram, you need the intersection of C and D, as well as what is in C and not in D. Remember, there's the intersection and what is outside the intersection, but still inside set C. So we just substitute. We have 4/7 being equal to the probability of the intersection plus the third. Then we make the probability of the intersection the subject of the formula, and then we evaluate. So next up, the probability that D occurs. Now for the probability of D to occur, remember the conditional probability we were given there. So if we rearrange what we said at the start, we have the latter event, we take it down here. So you'll be saying if it is probability of C occurring given that D has taken place, it will be written as probability of C and D on the numerator, and then on the denominator we have the latter, which is event D. So we now just substitute the probability of the conditional probability of C given that D has taken place. We said it's 5/14, and then we have the intersection. We now found the intersection. We found the intersection on the previous part A. It's 5/21. Then all this we divide by the probability of D. We divide this by the probability of D. So after this, we just make probability of D subject to the formula. So it's essentially 5/21 divided by 5/14. And we should get our answer is 5/21 divided by 5/14. And we should get our answer is 2/3. Now for the last part, we have to look for the conditional probability that D occurs given that C has already taken place, right down here. So we need the probability of the intersection, and then we need the latter. So the latter in this case is now event C. So we substitute. Well, conditional probability of D occurring given that C has taken place, we need the intersection. So the intersection of C and D will be the same as the intersection of D and C. So the probability of the intersection, we found it to be 5/21. And then probability of C occurring, we found it up there. We found it. And the probability of C occurring, we found it up here. We were given, in actual effect, we were given this already. The probability of C occurring is 4/7. So then we just punch that in the calculator. We have 5/21 divided by the 4/7. So we have our 5/12. So that's how we work with conditional probability. Thank you.